You think reality is solid. You think objects exist exactly where you see them. Time flows forward evenly, and space is just an empty stage where things happen. That picture feels obvious, it feels natural, and it is almost entirely wrong. Your brain did not evolve to understand reality. It evolved to keep you alive. That distinction matters more than most people realize. The world you experience is not reality itself. It is a compressed, simplified model, a survival interface, just enough detail to avoid danger, find food, and recognize patterns. Everything else gets thrown away. Take vision. You think you are seeing the world directly, but you're not. You are seeing a tiny slice of the electromagnetic spectrum. Radio waves, X-rays, gamma rays, all of that is invisible to you, yet just as real. Even what you can see is processed, delayed, color-corrected, and reconstructed inside your brain. By the time you see something, it already happened a fraction of a second ago. Look at a star in the night sky. That light may have left the star thousands or millions of years ago. The star might not even exist anymore. So what are you really looking at? Not reality as it is, but reality as it was. Every direction you look in space is also a direction back in time. The universe does not present itself live. It presents itself as a recording. Already your intuition is in trouble. Now consider space itself. You imagine it as empty, a void, nothingness between stars and galaxies. Physics says otherwise. What we call empty space is full of activity. Quantum fields fluctuate. Particles briefly appear and vanish. Energy exists even in the vacuum. The emptiest region of space is not truly empty. It is the lowest energy state of something very real. Then there's matter. You think this chair, your hands, your body are solid. They are not. Atoms are mostly empty space. The nucleus is tiny. The electrons are not little balls orbiting neatly. They are probability clouds. When you touch a surface, nothing actually touches. What you feel is electromagnetic repulsion between fields. Solidity is an illusion created by forces, not contact. Gravity might be the biggest deception of all. You think gravity is a pull, a force reaching out across space. That idea works well enough for throwing balls and predicting orbits, but it's not the truth. According to general relativity, gravity is geometry. Mass and energy bend space-time, and objects move along those curves. The Earth doesn't orbit the Sun because it's being pulled. It's following the straightest possible path through curved space-time. Your intuition wants space to be rigid and time to be absolute. Reality refuses. Time is especially misleading. You feel it flowing. You feel the present sliding into the past. But physics finds no flowing river. Time is not a thing moving. It is a way of ordering events. And it does not behave the same everywhere. Move fast enough and time slows down. Sit near something massive and time slows down. Two clocks placed in different conditions will disagree about how much time has passed, and both will be correct. Even now is not universal. Events that are simultaneous for you are not simultaneous for someone moving relative to you. There is no single present moment shared across the universe. Reality is not divided into neat slices of time. It is a four-dimensional structure of events, and how you slice it depends on how you move. At small scales, reality becomes even stranger. In quantum mechanics, particles do not have definite properties until they interact. An electron does not have a precise position, it has probabilities. Light behaves like a wave and a particle, depending on how you look at it. Measurement is not passive observation, it is participation. The act of measuring changes what is measured. This is not philosophy, it is experimental fact. Your brain desperately wants reality to be stable, local, and intuitive. Physics shows us a universe that is relational, probabilistic, and deeply unintuitive. The problem is not that reality is weird. The problem is that you are trying to understand it with instincts shaped on the African savanna. Feynman understood this better than most. He didn't trust intuition, he trusted experiments. And the experiments say the same thing over and over again. The universe is not obligated to make sense to you.
Reality is not what it looks like, not what it feels like, not what common sense suggests. And once you truly accept that, you're ready to go deeper. If reality were truly random, nothing would last. No atoms, no stars, no life. Pure chaos destroys structure. And yet, the universe is filled with patterns, repeating, stable, recognizable structures that persist over billions of years. This seems like a contradiction. How does order arise in a universe ruled by probability? The answer begins with statistics, not intention. Take a box of gas. The molecules move randomly, colliding in every direction. There is no plan, no coordination, and yet, over time, the gas spreads out evenly. Why? Because there are vastly more ways for the molecules to be spread out than to be clumped together. The system naturally drifts to the most probable arrangement. This is entropy, not disorder as chaos, but disorder as likelihood. Entropy doesn't force things to fall apart. It simply makes certain arrangements overwhelmingly more likely than others. Now apply this idea to the universe. In the early universe, matter was almost perfectly uniform. Almost, but not quite. Tiny fluctuations in density existed. Slightly denser regions had slightly stronger gravity. Gravity amplifies differences. Denser regions pull in more matter, becoming denser still. Over time, those small irregularities grow into stars, galaxies, and vast cosmic structures. The universe didn't need instructions to build them. It needed only gravity and time. This is a crucial idea. Order can emerge from randomness when the rules allow it. Stars form because gravity concentrates matter. Galaxies form because angular momentum organizes motion. Planetary systems form because energy is dissipated and stable orbits remain. None of this violates entropy. In fact, local order is created by increasing disorder elsewhere. A star shines by dumping entropy into space. Life exists by exporting disorder to its surroundings. Complexity is not a rebellion against entropy, it is one of its consequences. Your body is a pattern that happens to work. Your brain is an even delicater one. Neurons are simple. They fire or they don't. But connect billions of them with feedback loops and something remarkable happens. Thought emerges. Memory emerges. Consciousness emerges. Not as a separate substance, but as a pattern of activity. You are not a thing. You are a process. This idea, emergence, is one of the most important in modern physics. At different scales, the same system obeys different effective rules. Temperature doesn't exist at the level of individual molecules. Pressure is meaningless for a single atom. Yet at large scales, these concepts become real and measurable. They are not illusions, they are emergent truths. The universe works this way at every level. At the quantum scale, probabilities rule. At the human scale, objects behave predictably. At the cosmic scale, galaxies form vast filaments and voids. Each level emerges from the one below it. No level violates the laws beneath it, but none of them can be fully explained without them. Even light creates patterns. In the double-slit experiment, individual photons arrive one by one, seemingly at random, but over time, an interference pattern appears. Order emerges from uncertainty, not because photons communicate, but because the rules of quantum mechanics constrain the probabilities. Crystals form the same way. Atoms settle into regular lattices because that configuration minimizes energy. Snowflakes grow intricate shapes because of simple molecular rules interacting with changing conditions. No two are identical, yet all follow the same underlying physics. The universe does not build with blueprints, it builds with constraints. Once you see this, you stop asking why the universe wants complexity. Wanting has nothing to do with it. Given energy, matter, and enough time, patterns are inevitable. Some last briefly, some persist for billions of years. A few become aware enough to ask questions. That's you. You are a temporary pattern in a universe of patterns, maintained by energy flow, bounded by entropy, shaped by physical law. There's nothing supernatural about it, and nothing trivial either. It is one of the most astonishing consequences of simple rules applied relentlessly over vast scales. Order is not fragile. It is not rare. It is what naturally happens when chaos is constrained. And now that we understand how patterns form, we're ready to confront the deepest question of all. What are the rules that constrain everything?
So far, we've seen that reality is not what it seems, and that order can emerge from chaos without intention. Now we reach the unavoidable question. Why does any of this work at all? Why does the universe obey rules instead of behaving arbitrarily? Physics answers this with something both simple and unsettling. The universe runs on a small set of laws and constants that appear to be the same everywhere, always. Start with the laws themselves. Motion, energy, momentum, charge. These quantities are conserved. They don't disappear or appear without accounting. This is not a coincidence. Conservation laws arise from symmetries. If the laws of physics are the same today as yesterday, energy is conserved. If they are the same everywhere in space, momentum is conserved. Order exists because the universe does not change its rules depending on location or time. But those laws are not enough. They require numbers, constants. The speed of light, Planck's constant, the gravitational constant, the charge of the electron. These values are not derived from deeper principles we currently know. They are measured, and they're strangely precise. Change any of them slightly, and the universe collapses into triviality. Stars wouldn't burn steadily. Chemistry would fail. Structures could not persist. This is not evidence of design. It is evidence of sensitivity. The universe is balanced on a narrow range of possibilities where complexity is allowed. We do not know why these values exist. We only know that without them, nothing interesting would happen. Now combine these constants with relativity. Space and time are not separate. They form space-time, a unified structure that can stretch, bend, and distort. Mass and energy tell space-time how to curve. Curved space-time tells matter how to move. This is gravity, not as a force, but as geometry. Push this to the extreme and you get black holes. A black hole forms when matter collapses so densely that space-time folds in on itself. The escape velocity exceeds the speed of light. Events inside the boundary, the event horizon, can no longer affect the outside universe. Time slows dramatically near this boundary. To an outside observer, objects appear to freeze as they fall in. To the falling object, time continues normally, at least until tidal forces tear it apart. At the center lies a singularity, a point where density becomes infinite and our equations break. This is not a real object in the usual sense. It is a sign that our theories are incomplete. Black holes mark the boundary of understanding, where relativity and quantum mechanics collide. And that collision is the deepest problem in physics. Quantum mechanics governs the small. Relativity governs the large. Both are extraordinarily accurate. Both are experimentally confirmed, and yet they are mathematically incompatible at extremes. The universe runs on two rule books that don't fully agree, and we don't yet know how to reconcile them. Time itself becomes unstable in this conflict. In quantum theory, time is a background parameter. In relativity, time is dynamic. It stretches, slows, and curves. When you try to describe the universe as a whole, especially its beginning, time stops behaving like something you can measure cleanly. Which brings us to the beginning. The universe is expanding. Run the equations backward, and everything gets hotter, denser, closer together. Eventually, you reach a point where our laws fail. We call this the Big Bang, but that name is misleading. It was not an explosion in space, it was the expansion of space itself. And here's the uncomfortable part. Asking what happened before the Big Bang may be meaningless. If time itself emerged with the universe, there is no before. Asking what happened earlier is like asking what is north of the North Pole. The question assumes a dimension that may not exist. Finally, the future. Observations show that the expansion of the universe is accelerating. Galaxies are moving apart faster and faster, driven by something we call dark energy.
We don't know what it is, we only know its effect. If this continues, the universe will grow colder and emptier. Stars will burn out, matter will decay, energy will spread thin, entropy will approach its maximum. This is heat death, not an explosion, not a collapse, but a slow fading into uniformity. And yet, within this vast, indifferent process, complexity arose, consciousness arose, meaning arose, not written into the laws, but created by patterns that lasted long enough to reflect. You are one of those patterns. The atoms in your body were forged in stars. The laws that govern galaxies govern your thoughts. The universe is not separate from you. You are what it does in this moment. Feynman understood this deeply. The goal of physics was never comfort, it was honesty. And the honest picture of reality is strange, subtle, and astonishing. Reality is not intuitive. It is not centered on you, and it is far more beautiful than the stories we invent to simplify it. If this changed the way you see reality, that's the point. Physics isn't about comfort, it's about honesty. And the honest picture of the universe is stranger, deeper, and more beautiful than our instincts ever prepared us for. Richard Feynman believed that understanding reality, even imperfectly, is one of the greatest adventures the human mind can take. And this journey doesn't end here. Every question leads to another. Every answer opens a deeper mystery. If you want to keep exploring the universe the way Feynman did, without shortcuts, without myths, without comforting lies, then stay here. Like this video if it stretched your intuition. Subscribe if you want to keep pulling on the loose threads of reality. And tell me in the comments what idea unsettled you the most. Because the moment you stop being confused is the moment you stop learning.